Hi everyone, Assalamualaikum. In this video, we are going to discuss the last chapter of the syllabus, which is the function of 2 and 3 variables. Right? Now, we look at some examples that involve the function of 2 and 3 variables. Okay? First, we look at the function for two variables. Okay, let's say we have function f in variable x and y equals to 2x squared plus y. Okay, then we have function f in terms of variable x and y equals to xy minus 3y squared. And let's say we have function f in terms of variable x and y equals to 2x plus x cubed y. Okay, and then for the function in three variables, let's say we have f x y z equals to x squared z plus 3y minus x. Then let's say we have f x y z equals to x y z minus 2y squared plus z squared. And let's say we have f x y z equals to 2xy plus z cubed y. Alright, these are the function of two variables. Okay, for the function of two variables, let's say variable x and y, we will have partial derivative with respect to the variable x or partial derivative with respect to the variable y. Alright, and for the function of three variables, let's say variable x, y, and z, we will have partial derivative with respect to variable x, or partial derivative with respect to variable y, or partial derivative with respect to variable x. Right? What is partial derivative? In mathematics, a partial derivative of a function of several variables is its derivative with respect to one of those variables, with the others held constant. Right? Now we look at the notation of partial derivative. Let's say we have u equals to function f in terms of variable x and y, means in two variables. Okay? The partial derivative with respect to the variable x is variously denoted by, alright, for function u, we can write ux, okay, for the partial derivative with respect to variable x, okay. And for function f, we can write fx. That is partial derivative with respect to variable x, right? Or we can write del u over del x, okay? Or del u in numerator over del x. And for function f, we can write del f over del x. Or we can write del f in numerator over del x, okay? This is the symbol of partial derivative with respect to variable x for two variables, let's say x and y. Alright, let's say if we have three variables, x, y, and z, we use the same symbol to denote the partial derivative with respect to the variable x. Alright? And the stylish D symbol in the notation is del D, or curly D, or roundback D. It is not usual derivative D, or delta. Okay? From u equals to function f in terms of variable x and y, the partial derivative with respect to the variable y is variously denoted by uy or fy. Okay? The other symbol we can write del u over del y, or del u in numerator over del y, For function f, we can write del f over del y or del f in numerator over del y. These are the symbols used for partial derivative with respect to the variable y. Alright? It is similar to the partial derivative with respect to variable x, but now we replace by y here. Okay? To denote the partial derivative with respect to the variable y. Right? Let's say if we have function of three variables, variable x, y, and z. Okay, to denote the partial derivative with respect to the variable y, we still use the same symbol. Alright? If we have function u equals to f, x, y, and z, means the function of three variables, we can also have the partial derivative with respect to the variable z, and is variously denoted by uz or fz. Okay? Or we can write del u over del z or del u in numerator over del z. For function f, we can write del f over del z or del f in numerator over del z. These are the symbols used to represent partial derivative with respect to the variable z. Alright? Alright, now we recall back the simple derivative. Okay, let's say if we have function f equals to 2x cubed plus 4. Okay, then we differentiate with respect to x. So we can write f prime equals to, when we differentiate 2x cubed plus 4, we get the final answer equals to 6x squared. Okay, how we get this? Okay, when we differentiate f, the symbol become f prime x in simple derivative. Okay, and then if we have multiplication by constant here, we just keep the constant in front after we differentiate. Okay, and then we differentiate x cubed using power rule. So we get 3x squared. Okay, and then here is a constant. So when we differentiate constant, it equals to 0. Okay, and then after we simplify, so we get 6x squared. Okay, when we differentiate constant, it becomes 0. Okay, when variables multiply by a constant, we just keep the constant in front after we differentiate. Okay, then we just differentiate the variables. Alright, so after that, we simplify, then we get the final answer f prime equals to 6x squared. Alright, the idea is when we multiply by a constant, we just keep the constant in front, and when we plus or minus constant, after we differentiate, it becomes 0. Okay, if we differentiate constant only, it is equals to 0. But if the constant multiply by a variable, we need to keep the constant in front. Okay, then we differentiate the variable. Alright? Alright, let's say if we have simple derivative f equals to cx cubed plus c. C here is a constant. Okay? When we differentiate with respect to variable x, the final answer f prime x equals to 3c x squared. How we get this? Alright, when we differentiate f, the symbol is f prime. And then now we have multiplication by constant. So we just keep the constant in front after we differentiate. Okay? And then we differentiate x cubed here using power rule. So we get 3x squared. Okay? And then plus here, so we differentiate one by one. So after that, we differentiate plus c here. C is a constant. So when we differentiate any constant, the answer is 0. Okay, so we put plus 0 after we differentiate. Okay, then we simplify. So after we simplify, we get 3c x squared. Okay. Now, we look at the example for partial derivatives of two variables. Example 1a. Given fxy equals to xy minus 3y squared plus 2x cubed. Find its partial derivative with respect to x. When we find the partial derivative with respect to x, to avoid confusing, we put variable x at the back. Okay? Like this. We rewrite fxy equals to, alright, the original function is given in terms of xy. Now we write yx. Okay, we put variable x at the back. And then minus 3y plus 2x cubed. And we treat y as a constant. We just imagine y is a number like 2 or something. Right? So y is a constant because now we want to find the partial derivative with respect to x. Okay, so we assume or we treat y as a constant. And variable y here is a constant, so 3y squared is also constant. And then 2 here is constant. And then we can differentiate with respect to x. Okay? We find the partial derivative with respect to x. Okay? And the symbol when we differentiate using partial derivative with respect to x is fx. Okay? Alright, so when we differentiate yx, it becomes y times 1. Okay? We treat y as a constant. So, the derivative of yx with respect to x is y. We just imagine y equals to 2. Then, the derivative of 2x is 2. Okay? The derivative of 2x with respect to x, okay, equals to 2. We imagine y equals to 2. Or multiplication by constant y. Keep the constant y in front and then we just differentiate x. When we differentiate x, it equals to 1. Alright? And then when we differentiate any constant, it becomes 0. Okay, because we treat y as a constant. So, 3y squared is also constant. And the derivative of a constant is 0. Or, we just imagine y equals to 2. Then, 3 times 2 squared equals to 12. Okay, it's also a constant. And the derivative of a constant is 0. Right? And then, the derivative of 2x cubed, we already know, equals to 6x squared. Okay? Or, multiplication by constant 2, we just keep the constant 2 in front and then we just differentiate x cubed. When we differentiate x cubed, we can use power rule. So, it becomes 3x squared. Alright? Then we simplify. So we have fx equals to y times 1 equals to y. And then minus 0, no need to write. And then 2 times 3x squared equals to 6x squared. This is the final answer when we differentiate fxy, the function of two variables, using partial derivative with respect to x. Right? Now, we look at the same example, but this time we want to find its partial derivative with respect to y. When we find the partial derivative with respect to y, to avoid confusing, we put variable y at the back. Okay? The given function is already given variable y at the back. Okay? Let's say we write variable y in blue color. So now we have fxy equals to xy minus 3y squared plus 2x cubed. Okay? Alright, now we treat x as a constant. Okay? Because we want to find its derivative with respect to y. So we treat x as a constant. 3 is also constant. And then x we treat as a constant. So 2x cubed is also constant. Alright? And then we can find the partial derivative with respect to y. The symbol for partial derivative with respect to y is f and then subscript y. Okay? Alright, since we treat x as a constant, so we still have x here and then we differentiate y. So it's become 1. Okay? We treat x as a constant. So the derivative of xy with respect to y is x. Or we just imagine x equals to 3. Then the derivative of 3y with respect to y equals to 3. Or multiplication by constant x. We just keep the constant x in front and then we differentiate y. When we differentiate y, it is equals to 1. Right? Alright. And then now we have 3y squared. The derivative of 3y squared with respect to y is 2 times 3. So we get 6 and then y reduce 1 from the original power. So we get 6y. Okay? Or multiplication by constant 3. We keep the constant 3 in front and then we just differentiate y squared with respect to y using power rule. So we get 2y. Okay? And then we treat x as a constant. Okay? So 2x cubed is also a constant. And the derivative of a constant is 0. Right? Or we just imagine, let's say x equals to 3. So 2 times 3 cubed equals to 54. Is also a constant. And the derivative of a constant is 0. Right? After that, we can simplify. Partial derivative with respect to y, f, and then subscript y equals to x times 1 equals to x, and then minus 3 times 2y equals to 6y, and then plus 0. No need to write. This is the final answer for partial derivative with respect to y. Right? Coming up next, partial derivative of two variables. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.